Did you know a machine can fail because of the people trying to fix it? A centrifugal compressor kept breaking down, always within days of scheduled maintenance. New bearings, new seals, new everything. Engineers ran every test imaginable. Nothing made sense, until someone finally watched the technician reinstall the impeller. It had been going in backwards, every single time. For months, the maintenance was the failure, and that's the part nobody wants to admit. We assume competence. We skip verification. We trust the process without watching the process. Don't just fix it. Confirm it was fixed correctly. Did you know a single wrong number can destroy a machine hundreds of times before anyone notices? A heavy industrial gearbox kept failing. New bearings, fresh oil, perfect alignment every time, but it kept eating itself alive. Then one engineer pulled the original lubrication spec sheet and compared it to the PM manual. The viscosity grade was wrong, had been wrong for years. One bad transcription copied into every maintenance cycle without question. The gearbox was never the problem. The paperwork was. Lesson learned? Your maintenance manual is only as reliable as the person who wrote it. Verify the source, always. Every calibrated machine can lie to you. And the scary part? It does it perfectly. A precision line starts making out-of-spec parts, but only in the afternoon. Every morning inspection? Flawless. The machine checks out every single time. Days of troubleshooting. Nothing. Then someone measures the machine bed at 7 in the morning, and again at 2 in the afternoon. The metal had grown, thermally expanded as the shop warmed up through the day, by just enough to quietly shift every cutoff tolerance. The machine was never broken. Physics was just running a shift nobody scheduled. Map your thermal environment, because invisible forces follow no inspection checklist.
Did you know the drive saving your plant money might be silently destroying your motors? Variable frequency drives cut energy costs, but they create high-frequency voltage pulses that build up on the motor shaft. When that voltage gets high enough, it discharges straight through the bearings. The result is a pattern called fluting. Tiny craters burned into the bearing race in perfect, evenly spaced lines. It looks like wear. It acts like wear. But replacing the bearing fixes nothing, because the electricity just burns through the new one too. The fix is a shaft grounding ring. One small part. That is it. Follow for more engineering nightmares. Did you know the most dedicated technician on your floor might be destroying the most equipment? Here's the trap. A bearing runs warm. The technician adds more grease. It gets warmer, so he adds even more. But over-greasing doesn't protect a bearing. It churns the lubricant into heat, collapses the oil film, and spins the bearing straight into failure, faster than if he had never touched it. The fix is simple. Follow manufacturer grease intervals exactly. More is not better. The hardest lesson in maintenance? Sometimes doing less is what saves the machine. Follow for more engineering nightmares. Did you know a perfectly aligned pump can destroy itself within hours of startup? Here's why. When engineers align a pump cold, they hit laser-perfect tolerances. Zero error. Textbook precision. But then the machine heats up. Metal expands. The shaft rises. The coupling shifts. And that flawless cold alignment becomes a serious misalignment at operating temperature. The bearings take the hit first, then the seals, then the shaft. Experienced engineers account for this by calculating thermal growth offsets before alignment even begins, so the machine aligns itself as it heats up. Follow for more engineering nightmares. Did you know a single loose foot can destroy a machine from the inside out? The pump keeps failing. Bearings gone. Vibration through the roof. The team checks balance. They check alignment. They replace parts. Nothing works. Nobody checked for soft foot. When one of the machine's feet doesn't sit flat against the base plate, the entire frame twists under bolt load. That distortion travels straight into the shaft. Alignment becomes impossible. Bearings wear out fast. The fix? Slide a feeler gauge under each foot before you torque a single bolt. Follow for more engineering nightmares. Did you know a compressor can destroy itself in under 3 seconds? It starts with a thud, then a violent shudder you feel in your chest before you even hear it. That's surge. The airflow inside the compressor collapses, reverses, and slams back through the machine in a wave of pressure. Over and over, like a hammer hitting the blades from the inside. Bearings crack, seals blow, impeller blades bend or shatter completely. Experienced operators don't need instruments to recognize it. They feel it. And they know every second of hesitation costs weeks of repair. Follow for more engineering nightmares. Did you know the oil inside a journal bearing can actually turn against the machine it's supposed to protect? At high speeds, the oil film stops holding the shaft steady and starts pushing it in circles, orbiting at roughly half the shaft's rotational speed. Engineers call this oil whirl. Left unchecked, it locks into resonance and becomes oil whip, and that's when bearings fail violently. The worst part? The vibration signature looks almost identical to imbalance or misalignment, so most teams never find the real cause. Follow for more engineering nightmares. Did you know swapping just 2-phase wires on a 3-phase motor makes it spin completely backwards? On commissioning day, the panel reads normal. The motor accelerates. Everything looks fine. Then the pump starts making a sound it shouldn't. When a centrifugal pump runs in reverse, the spinning impeller slowly unscrews itself right off the shaft. On a compressor, the damage happens in seconds. The fix takes 30 seconds before startup. Swap any 2-phase wires, then bump the motor and confirm rotation direction before you go full speed. One step. Saves everything. Follow for more engineering nightmares.